wouldn't use anything for that then? And then for this one, is it like velocity between 2 points? So you would give us 2 points and then ask us to find the velocity, or would it be instantaneous?
Or I have a function that allows you to find the velocity at that point in time. So I did the calculus for you, and I have a function that allows me to find velocity at this point in time. It's a function. So it's just a formula that lets me figure it out.
So that is the formula?
Yeah, this is not the same thing as average. This is not talking about an entire trip. This is saying right now.
So that is an equation for instantaneous velocity that we can
Yes.
find, but only with this kind of graph.
Only with this kind of graph, or if I give you a word problem. Right, you've seen this formula before. Final velocity equals acceleration times time plus initial velocity. You've seen it before. So it's just how we get the formula. It's from a graph. Yeah.
So BF doesn't have to be the end of a line. It can just be any point.
It can be anywhere along there. It just depends on what t you're using. If you're using t all the way at the end of your motion, then yeah, you have final velocity. If you're using time halfway through your motion, then you have the velocity for halfway between. Yes?
So if you had a velocity time graph and
Yep.
you were trying to find something about it, would you instantly know that that's the equation to find whatever you're trying to get from the graph?
Sure. Your question's a little vague, but I think yes
Like,
is the
would
answer.
you use, you know how for the position time graph you found x equals
I found position equal to average
Right.
velocity times time.
So that would be like for a position time graph.
Yes.
That equation.
Okay. Let's look at some trends for boys. For both constant velocity and for constant acceleration. If I make a position time graph, I make a velocity time graph, I make an acceleration time graph. Same thing here. Position time, velocity time, acceleration time. Now, my graphs are simply sketches. I have no numbers. They're simply sketches. I can tell positive and negative as whether or not I'm above or below the zero line, but other than that, I can't determine any values. When I have constant velocity, then I know my velocity time graph is a flat line. It's some constant value. And because velocity doesn't change, and by definition acceleration is a change of velocity, then my acceleration is always zero. And when I have a constant velocity, that means for my position time graph I have a constant slope, which means it looks like that. Okay? The tricky one is when I actually have some acceleration. And I'm going to go with a hard example. I'm going to give us a negative acceleration. My acceleration is negative, which means that my change of velocity will be negative. Does that mean that I necessarily slow down? No, it doesn't mean that I have to slow down. I'm going to start right here. I'm picking a random starting point. I'm starting with a positive velocity. And positive velocity simply means that I am moving forward. My displacement is a position that is increasing. If acceleration is the slope of my velocity time graph, then the slope here should be negative. Acceleration is negative, and if that indicates slope for velocity time, then I need this to be negative. Well, look at that. It passed zero. So I was walking in the positive direction for a little while, then I was walking in the negative direction. And in between going positive, is this positive for you?
Yeah.
In between going positive and then going negative, at some point I had to stop and turn around. Okay? So there's a very important point right here where velocity is zero. Very important point. Okay? Let's make that our dotted line for zero here, and this our dotted line for zero here. Before that dotted line, I am walking forward. At that dotted line, I stop. And after that dotted line, I'm walking backwards because I have a negative velocity then. Does it matter where I start my position time graph? Not unless I give you a number, and I don't have a scale here to give you a number anyway. So it doesn't matter where I start my position time graph. I can start it up here, I can start it at the origin, I can start at negative. Just for the sake of how I'm going to draw this, I'm going to start right here. begin by walking positive. I have a high positive velocity, which means here I have a high positive slope. I don't actually want to start there. I want to start right here. I have a high positive slope. So I'm going to construct my velocity time graph by drawing my slopes. I have a high positive slope. And then it becomes a less severe but still positive velocity. So a less steep but still positive slope. And then right here I cross the 0 line. So I have velocity 0, which means slope 0, which means a flat line. I was walking forward, forward, forward. I stopped so that I could turn around. Now I'm going to walk backwards. Somehow I'm going to decrease my position. Okay? Well, I start with a very small but negative velocity, which means I have a very shallow but negative slope. Shallow negative. And then my velocity, is this increasing or decreasing? Decreasing. It's decreasing, but my speed is getting bigger. Because a speed of -2, or a velocity of -2, has a lesser speed than a velocity of -7. Because it's the magnitude, not the direction that we care about for speed, okay? So my slope here becomes still negative, but more severe. For a position time graph that is curvy, all I really care about is the general curvedness shape of it. You're not going to be perfect. My graph's not perfect either, but the general shape should be true. I think it's always easiest to start with your acceleration time graph and then work your way up, because the acceleration time graph will dictate to you what the velocity time graph looks like, which will dictate to you what the position time graph looks like. Okay, so start with the flat one. The flat one's the easy one. Do you have a 0 acceleration? Do you have a positive acceleration or a negative one? Easy as that, yeah.
On the test, so you have like on the review packet how you have like position, velocity, and acceleration, and sometimes you switched off. Like sometimes you gave us velocity, and we have to figure out position and acceleration.
You have to be able to do that, yes. But if I give you a position time graph, you should easily be able to tell. Is it a straight line, then it's constant velocity. Is it curvy, then it's constant acceleration, yeah.
When going from like acceleration to velocity and stuff, how do you know if velocity goes below the x-axis, or does it matter if you just drew it all in the like first coordinate and then touched it at the very end? Could you do that?
If all I gave you was the acceleration graph, then yes.
Okay.
It is possible that your velocity stayed positive and just continued to
So how would
decrease.
you be able to tell if you just got the?
I would have to give you that direction.
Oh, okay.
Diego?
If we had a constant position time graph, we would know that the velocity would be 0.
Yes.
So the velocity, it would be a line straight down the would be the acceleration.
And you're going to bold the x-axis so that I know you didn't leave that blank. And then what does your acceleration time graph look like in this case?
That's what I was asking.
Acceleration indicates a change in velocity. Does my velocity change?
No.
So acceleration should be 0. So I know you didn't just leave it blank, you make the x-axis bold. It should indicate 0, yeah.
Okay, so for the second one, velocity time, it's like the same question as Marla, but I just wanted to double check. So you don't have to go past the x-axis?
Unless I tell you that you change direction, which indicates that you have a velocity of 0 at some point, then you wouldn't, if all I gave you was this, the acceleration time graph, then you wouldn't necessarily know that your velocity goes from positive to negative unless I tell you that.
How would you tell us that? By giving us position time? Or like
By writing in your directions somewhere that your object changes directions.
Should we start with a curvy acceleration line?
No. If you have a curvy acceleration line, then you have what we call in physics a jerk. We don't talk about jerks. We don't like jerks. We don't talk about jerks. Someone else had their hand up though.